And welcome back to this special edition of TI Now here at the Open Networking Summit. We're talking with Kelly Harrell, Senior Vice President and General Manager of Software Networking at Brocade. And Kelly, welcome to the program.
Hi, thanks for having me.
Oh, thanks for being here. I was mentioning in our pre-show conversation about a number of presentations you've done on the new IP. What is this? What is this, the new IP?
Well, the new IP is a response to a lot of different forces that have basically overwhelmed traditional IP networking. And we can get into the detail, but the things that are really the hallmarks of the new IP, first is the concept of openness. But not just openness for any reason, it's open with a purpose. The second is that there's a very high software quotient to new IP infrastructure, whereas typically it was traditional black boxes. Now you see a lot of software as part of the actual infrastructure in an IP network. I think the third element is really that there's a strong ecosystem driver element to the new IP. It's not single vendor. It's about vendor heterogeneity and the absence of lock-in, the inverse of which is new opportunity for network designs. So all of this is in pursuit of a much higher level of agility, much lower level of cost, and in a nonlinear function jump here. So it's basically a new way to approach the network design and a new type of network infrastructure that leads you to that design.
Kelly, of course, we're here at the Open Networking Summit, as I mentioned. A lot of talk around network functions virtualization, SDN, software-defined networking. How does that play a role in the new IP?
Well, the new IP is about finding new levels of agility and step function improvements in the cost for IP networking. And to get there, we need to advance the network infrastructure itself beyond the traditional black box and begin to decouple it to provide capabilities that allow for the leveraging of innovations across each part of the system design, whether that's the hardware or the software. And the concepts of NFV and SDN imply a very high degree of software in the overall network design. So with the objective of making a real step function improvement, nonlinear improvement in the agility and in the cost of the network, you need to decouple the systems. As you decouple those systems, you introduce concepts like NFV, where a physical router now could be a virtual router, or a physical firewall could be a virtual firewall. And that's just a step in that direction. Above that layer is a layer of abstraction, which allows us to manage the network much more efficiently, get it to do what we want it to do when we want it to do that. So NFV and SDN are key components of a new IP network.
Now, you may or may not know, but TIA's membership base are equipment suppliers, equipment vendors. There was a fear or concern a couple of years ago, and even now, about their equipment being commoditized. Has that switched or transitioned from a fear or concern to more of an opportunity now for them?
Well, I think it really depends on the vendor. For disruptive vendors, it's an opportunity. For incumbents, it may be a challenge, depending on how your business model is structured. If your business model is designed around selling traditional, very expensive hardware, this could be a very painful shift. However, if you are looking at this from a vendor perspective as a new opportunity, then it's all greenfield in terms of how you would address it from a business strategy. Often, though, the concern comes into play from a vendor standpoint about commoditization. And this is really, I would frame it differently. I would say that concepts like efficiency and effectiveness can now be viewed independently as opposed to all within one black box. So you can say certain aspects of the network require a high degree of efficiency, other ones have a high degree of effectiveness required. And when you have a single black box, you have to trap both of those concepts in one design. But now what you have in this new IP world is this decoupling of system design. So you have hardware, which is increasingly standard hardware, which does imply greater cost efficiency. And the value transference is moving into the software, which is where the effectiveness really comes into play. So, it's commoditization, but it's also kind of a creative deconstruction and reconstruction of system infrastructure. So it really depends on the perspective of the vendor.
Kelly, I want to go back 2-3 years once again to the climate back then that proved to be the catalyst for SDN, NFV, and ultimately the new IP.
Yeah, a few different things. I think on the one hand, you've got this combination plate of cloud, of big data, of social and mobile, where the user base has just exploded. The data rates have exploded. The amount of data that we're moving is just it's not a linear growth model. It's an exponential growth model, and traditional IP networks have strained to be able to scale efficiently underneath that growth load. Then on top of that, you have new dynamics such as the Web 2.0 types of vendors and over-the-top traffic, which is actually for service providers changing the strategic issues that they have to deal with over and above just the infrastructure growth itself. So that combination of new parts of content and new methods of accessing content, how fast it's coming online, coupled with new age vendors against traditional service providers, is collectively created this unstoppable dynamic and requirement for a new IP.
Now, as I mentioned, I did watch a couple of your presentations as of recent. You said one thing that I thought was interesting. You said that you can't rid the network of complexity or rid complexity from the network, but you can tame that complexity. What does that mean?
Well, I think it's true with any organization or any design. When you ask more of it, it's going to get more complex in pursuit of delivering that. I think that's true of people organizations. It's certainly true of system designs, and it's true of networks. You look at just service chaining, concepts that we never applied before now are coming into view as a requirement, and that just does continue to increase the amount of complexity that is in the infrastructure itself. So the complexity is not going away. The complexity is actually growing, and that's just the nature of the beast. However, what we can do is we can tame the complexity through abstraction, and this is really where SDN comes into play. If you can put a layer of control over this complexity, get above that layer of control, and work with newer, more modern programming languages to be able to build applications that tell the controller what to do, then you've got automation and you've got leverage over this growing complexity in the system itself.
Kelly, of course, there's a transition in culture also with the vendors in the ICT industry from this vendor lock-in model to an open platform. Is that transitioning as easily as everybody wants to believe?
Again, I think that's a vendor-specific statement. If you're a dyed-in-the-wool kind of incumbent vendor, the challenge is going to be that what used to be a strength in your business model may be a liability now. To have locked up black box models that have 3-year change cycles before there's any innovation introduced into the industry. Maybe there was advantage that was inherent to the business model of the incumbent. However, now in this new world with systems decoupling, the pace of change is just radically faster. We're talking about pace of change in months as opposed to years. And the software element that is driving that change is as important as the new pace of change in the standard hardware elements as well. So the advantage, the value transference is moving up into software. The pace of change is dramatic. And the duration of an advantage is much, much shorter in this world. So the incumbent that is used to bringing something to market and sitting in that position for a long time is going to have a lot of discomfort with something that's so software driven, open, that's modular, and having to change as fast as it can. And that is a very difficult thing to address culturally, especially if you've got a couple of decades of having run under the former model.
Now we're living in a world of server-based network designs. How does that change the business cases for your partners, for your customers?
Yeah, that's an interesting question, because when we talk about network infrastructure, there's a wide range of types of gear that we can be talking about. It can be everything from a cost-reduced customer premise equipment device all the way to something much deeper in the network that has inherently much greater scale and aggregation capability. And so where if you're using servers across that new spectrum, then the question is, what is the cost advantage? So, and it comes down to two aspects. One, is there a CapEx advantage? Well, that depends on the class of infrastructure that you're taking out. And the second is there an OpEx advantage? So when you look at the cost, if you're deeper in the network with much larger traditional boxes, the power and cost effectiveness of a single server can be tremendous compared to the cost model of the large black box world. However, if you go further out to the edge of the network, where you have lots of small boxes, the server itself might actually be overcosted compared to what we're used to. So what is important in that world is that the infrastructure that you're putting into the server can be so dense that a server can accommodate lots of customers, so that you can amortize the cost of a single server across a lot of customers. So on the one hand, it's a single box that could replace a much more expensive single box. On another hand, it's a single box that might displace hundreds of smaller boxes into a single hole.
Kelly, I want to finish by asking you a future question, the impact of SDN and NFV on technologies and services. And I'll start with one technology, let's say 5G architectures.
Oh boy, yeah. Well, again,
it's a loaded question.
Well, here's an example of just, we're taking a big jump in the amount of bandwidth that needs to be passed through these architectures. And traditionally, the traditional model of network infrastructure is that every big jump in bandwidth capability had a big jump in cost associated with it. And that could be true everywhere from the cell tower all the way back to the virtual evolved packet core and then the GI LAN. So it used to be that every major step up had a concomitant massive step up in cost model for the hardware. So just in 5G, you can see elements that can be virtualized, be done in software on standard hardware, from the cell tower into the EPC and the GI LAN. So the biggest issue is that it's going to be able to facilitate that movement to 5G with a dampened impact from the cost model. But then also, once we've got these pieces virtualized, we have a lot more potential agility. We can turn on more services, turn them off, scale them up, scale them down much more easily.
I want to pick one service. I know there's a number of services now that even carriers are offering. Pick infrastructure as a service. What's the impact of SDN, NFV on that?
Well, I think this is really where a lot of the software networking got its initial track, was in cloud providers, which were infrastructure as a service types of plays. And the idea here was that you could get this scale across lots of servers and automation and all the benefits through virtualization and orchestration. And we had all of this wonderful benefit except for the network. The network was still, bring each box separately, cable them up. And this is where the idea of being able to use software in those types of environments for networking as opposed to hardware really began to pick up. And you saw it especially in the really big clouds where it's been alive for years. So now when you talk about other attributes and use cases of something as a service, and can be internal to a company, there are service providers now building their new infrastructure designs assuming this XaaS kind of an infrastructure. And so the ability to use software for networking in those environments helps across a wide range of things. It helps in multi-tenancy environments. It helps with east-west traffic optimization. Then the ability to put SDN control over this is a key element for being able to really facilitate the kind of automation that we need in the network in order for it to match the kind of automation that we've got in the compute side.
Kelly, how about the impact of SDN NFV on the app ecosystem?
That's going to be interesting, actually, because which app, right? There's the traditional apps that we would think of, and there's also now applications that sit on top of an SDN controller. So there's going to be a new emergence of app ecosystem above that SDN controller, and then there's also going to be increasing amounts of network awareness being written into the compute apps themselves. So the compute app, and that's already happening at the compute app layer, but I think probably one of the more interesting things that's going to happen is going to be this explosion of apps that happen above the controller, where the controller is manipulating a whole network underneath it. And the first app is for a certain purpose, the second app is for a completely different purpose. We're going to have vendors producing apps, there are going to be customers producing their own apps, there's going to be third-party ecosystems. But the only way that the ecosystem can really blossom is if there's openness, if there's open interfaces and standards so that they know the technical requirements to be able to deliver the capabilities and then run them through in a tested system.
Kelly, it was a pleasure talking to you.
Yeah, thanks for having me.